All right, thank you. Good morning, everybody. Everybody is awake, I hope. Yes? It's early morning. I get to be the first one up. I get to warm you up. So what better way than to tell you all the secrets of Silicon Valley, right? Everybody's got their notebooks out, I hope. Can you see on stage? Let's see. So let's get the slides up, if we can, on the big screen. So you heard a little bit about me while they're getting that done. So I was born in Ukraine, right next door. I grew up in Silicon Valley, and I go back and forth now. I lead the investments for HP, which is the Silicon Valley's original startup. So how many of you recognize Bill and Ted here? Remember this movie, Bill and Ted's Excellent Adventure? Okay, we got one arm. So I should probably replace this slide because most of you are too young to remember this movie. But before Bill and Ted, there was Bill and Dave. Right, so HP is Silicon Valley's original startup. 1939, first round of investment was $538, about how much Eastern European accelerators give away now, right, for about 15% of the company. The first customer was Walt Disney. The first product was an audio oscillator, so a device to test audio. And today, the company is one of the greats. It's over 50 billion revenue per year. The company actually split in two a year ago, so this is about half of the company. We're the smaller brother. We have about 50,000 employees worldwide. We sell into 178 countries through 250,000 channel partners. So quite a dream, right? So this is kind of the journey from zero to hero. Now, I'm not here to give you a commercial on HP. I'm here to talk to you about you. And as entrepreneurs, I want to help you plan your career, plan your life, hopefully succeed. And there's a few things we have to talk about. So in a normal career, right, it's kind of an escalator. You get good grades in school, you get into a good college, you get into a good company, you get regular promotions, and then you retire, play golf, and die. All right, that's a normal career. This is what your parents want you to do with your life, right? So this is a little bit in the past. This doesn't exist anymore. Now, on the other hand, if you're a startupper, right, your career, everybody thinks it's going to be, start a company and become very successful overnight. Well, unfortunately, the story looks a lot closer to this, right? It's a very tumultuous, it's a very painful process, a very long process, right? Let's see. Oh, the slides are not even changing. I'm talking to myself here. Okay, let's go back. Guys, can we fix the slides? Okay. I'm going to do a little dance for you in the meantime. Okay, so let's talk about you. All right, actually, let me show you real quick. So a couple of slides you missed. Wow, this is a long delay. Let's see. Okay. Anyway, we'll try to make this work. So let's talk about you. All right, so this is a normal career. Let's see if that works. Yeah? Okay, good. Ooh, okay. Very slow. All right, so this is what people think a startup career looks like, right? In reality, it looks something like this. This is what I was trying to tell you, that it looks really, really painful and messy, and it's not just start a company and succeed the next day, right? One of my favorite quotes from Ben Horowitz: as a startup CEO, I slept like a baby. I woke up every 2 hours and cried, right? So Ben Horowitz started several companies now with Mark Andreessen, who kind of invented the web, at least, not the internet. They have Andreessen Horowitz, so I'm sure most of or all of you know about Andreessen Horowitz. So as a startup founder, you may look like Gandalf here at some point, because it takes a long time. It takes about a year to develop an idea and 2 years to figure out if anybody cares about your idea, right? If you're successful, it'll take you 5 to 8 years of your life, of your non-refundable lifetime, to see it through. So let's do some math, right? If you start right out of college at 22, you'll spend a couple of years messing around with your first startup. You'll likely fail. And then you'll probably go back to school or do something else for a couple of years, and then you'll be smarter, and then on your second one, you'll fail faster. You'll fail in a year, right? On the third one, you might already kind of start figuring out how this whole thing works. You'll spend about 5 years of your life. Congratulations, you're in your early 30s, okay? Then the next one will take you into your mid-30s. So if you don't find success, you maybe have 3 or 4 startups in you before you have to get serious, go get a job at a big company, and do your thing, kind of give up on the dream. I hate to say it. So you have to be very careful about what you invest your time into, right? And this is my hope, is to give you some ideas, right? It's a very tough journey, and my goal and job as a mentor is to help you improve your odds of success. And this means studying your craft a little bit, studying the craft of entrepreneurship. So there's 3 questions you have to ask yourself: how, where, and what you're going to work on, right? So let's talk about how, first of all. So what is a startup? A startup is an experiment in search of a business model. By design, it's not a business that is known, right? If it's known, there's already a lot of competition, there's really no opportunity, right? So a startup is not a small version of a large company simply because you don't know what your business is yet, right? You can't start building management and layers of structure and all of these things before you know what business you're in, right? So you start with an experiment, you look for a business model. When you find the product market fit, meaning you know who your customer is, how long it takes to sell them, how much it costs to sell them, where to find them, and how much they're going to pay you, you get the product market fit. You start building a repeatable sales model, and this is when you can start building a management structure around that, okay? Then you get into a very interesting period in your company's history, which is a transitioning from startup to a company. All right, so you become a company when you're about break even or profitable, you have about 150 people, you have different management groups, you have different structure, and suddenly it becomes really boring because every day is the same, right? You're not solving the same challenges. So by the way, very few founder CEOs go all the way through this whole process, right? I want to check if the slides are working. They're almost working. There's a video in this, it's totally not going to work. So we'll see. So this is supposed to say company. So most founder CEOs do not go through this process. They get bored, or the company becomes bigger than they know how to manage. About 2/3 of the time, the founder CEO, by the time the company reaches the company stage, is gone. Either left the company or becomes the CTO or the head of product, and a professional CEO is hired, right? Usually by the VC. So if we look at this academically a little bit, if we look at Clayton Christensen's S-curves of innovation, this is very important. Let's see if we can see it. Okay. So technology goes through this maturity stage. That's supposed to say maturity. This is really weird that it's cutting off there. So for a long time, you're working on a technology, right? And you're spending a lot of time and money in putting it into research, right? This is time, effort, investment, and expertise that it takes. And this is product performance, right? You have no product for a while. You're investing in new technology. And then suddenly, you have this period where this technology becomes a product. You can start building and selling products in it, right? This reminds you of a few things, right? So this is the sweet spot for building a startup. Now, this window is open for a short period of time with new technology. And at a certain point, it becomes mature, and this is where the large public companies kind of own the category. And it's very difficult to break through in that business. So timing is very important. I'm sure you've heard this before. But being too early means the technology is not ready for the market yet, or the market is not ready for the technology. And being too late means that you can't break through. You have to find the right time. So the other thing that makes startups very special is this concept of staged financing, right? Staged financing means that if you look over time, let's see if this animation actually works, kind of, sort of. Slowly but surely, we're getting there. Okay, so if you look at for a while, you're going to be burning a lot of money, right? You're doing research, you're building your product, you're trying to set up sales and marketing. At a certain point, you break even, right? Here you start selling and making money. You break even and you become profitable. So if you overlay this with the staged financing, this is what really makes the difference between a startup, a technology startup, and a lifestyle business, right? Because with a startup, you're going stage by stage. You have a concept, you raise seed. You start getting early validations, first customers, you raise Series A. And on and on and on, market traction, Series B, scale validation. You do this over and over again. And hopefully, after you get predictable scale, you'll IPO. Can you see it? Yes. So this is what a startup goes through ideally, kind of academically, right? It's always a little bit messier than this. But you wouldn't do the same thing with a restaurant, right? Because the concept is, well, you know how to run a restaurant. Everybody knows how to run a restaurant. Right, it's an old business, just to give you an example, or a consulting company or an outsourcing company, right? It's totally different business. So this is what makes it special. So if you look at the last 50 years in Silicon Valley, you can see the different S-curves of different technologies, integrated circuits, personal computers. This is where HP got in the business, right? Internet, nanotech, clean tech. A couple of these haven't actually turned into big companies yet. But you can see that these curves go up and through the different years. This is why venture capital invests in specific themes, right? Into buzzwords, into things that become hot. AI, VR, drones, right? All these things right now. Because all of these things are ready to be commercialized, and the next big company in each one of those categories is being built right now, right? So, we step back and look at the world a little bit. What is an innovation cluster? An innovation cluster has a few different components, and I have to keep checking the slides here. So, you certainly have entrepreneurs and venture capitalists, right? That's obvious. You need those two components for startups to work, but that's not enough. You need large companies. Oh, this is not going to work, is it? Okay, slowly but surely. So you need large companies that are going to be strategic investors, that are going to invest the billions of dollars into the research phase of the technology. They're eventually going to buy the companies in this space, because most companies don't go public, they get bought by larger companies, right? You need universities that are going to pump out the engineers and the MBAs that know how to run businesses, right? You also need management. So this is what makes Silicon Valley special, this little secret right here. You can get all these other things everywhere else, but in Silicon Valley and Silicon Valley only, do you have 50,000 director-level managers that have experience in building technology companies. So when any kind of startup needs to scale, usually they'll need to go to Silicon Valley if they want to build a company quickly, right? If they go from 20 people to 100 people in a year to 1,000 people, the only place you can find experienced managers in technology of that quantity would be in Silicon Valley. So that's a little secret. You also need professionals. These are the accountants and lawyers and other consultants that know how to work with these kind of companies. You also need the government. Here we go. It's almost there. So you also need the government, which creates the economic conditions for all of this to work. So if you study Silicon Valley history, the US government, the Department of Defense, was actually the first customer of Microwave Valley before it was Silicon Valley, before Silicon, when it was vacuum tubes, right? Because it was all the defense fighting the Cold War with the Soviet Union, right? It signals intelligence. And then after about 20 years, the US government wanted to start the innovation in Silicon Valley and started matching funds with venture capitalists. So all the venture capitalists were coming over from New York, from East Coast, and for every dollar they would invest, the US government would add $2, right? So Singapore has done this successfully, copied this model. Israel has done this successfully. Other countries should follow suit, right? All of this lives in large pools of private capital, right? So this is private money. And usually it's entrepreneurs that sell their company, they make a little bit of money, and they start angel investing in the next generation, right? And of course, all of this, public stock markets is where usually these companies are shooting for, and they may sell themselves to a big company or they may go public, okay? So that's a cluster of innovation. And why is that important to have a cluster? It's also important for competition. Let's see if this comes up. Yep. So it increases productivity of the companies if they're working closely together to their competition. It drives the direction and pace of innovation, right? And it stimulates the formation of new businesses. So one big reason for you to be in an accelerator is because you're going to be around other companies and you'll be able to feel how well you're doing. Because 10% will do really well, right? 10% will do really poorly, and everybody in the middle is going to learn from the top 10% and go faster, work better, right? If you look around the world, the top 20 startup ecosystems, this is getting a little dated. Let's see. Are we going to get there, guys? Oh, okay. Let's go back. That slide just doesn't want to load. Strange. Okay, so there are about top 20 ecosystems in the world, and Silicon Valley is, of course, number 1. Israel, Tel Aviv is number 2 now. It used to be Boston, and now Boston is in 6th place, right? Right after New York City, right before London. So there's an opportunity for many cities to quickly change position here. Now, this map here, so this shows you that US is not just one ecosystem as well. It's not all just about Silicon Valley. If you're starting a fintech company or an advertising company, you should probably move to New York. If you're starting an entertainment or content company, you should probably be in LA. If you're starting a jewelry company or some other types of business, you can see there are different innovation clusters. There's different industry clusters around the US as well, right? So now the last question, what should you be working on? Oh, this is brutal. Come on, guys, can we get the slides working? All right, so let's see. Here we go. No, that's me. Hi. Okay, so Chris Dixon, who's also at Andreessen Horowitz now. You see a pattern here? He was talking about the different eras of technology. So here we go. So the current era, right? So you can see that the PC era, here's where it was growing. Here's where the big companies are being built. Then internet era switched, now the mobile era. So the question is, where are we going next, right? If you make another app for the iPhone, there are 2 million apps in the App Store. It's going to be very difficult for you to stand out and build a big business around that. So the question is, what's next? Maybe it's wearable computing, maybe a few other things. So I'll tell you about 4 areas that we look at specifically that we think are very interesting. And the slide's not switching. So those 4 areas are hypermobility, smart machines, Internet of all things, and 3D transformation. And together, those things are blended reality experiences. Okay? Almost showing up. Okay. So hypermobility today. You think of hypermobility because you have high-speed internet in your pocket. It's a phone, it's a wearable device, it's a smartwatch, etc. If you look at hypermobility tomorrow, this is going to be nanocomputers. These are going to be computers that are inside your bloodstream, right? You're going to be communicating with devices and with each other through technology that's embedded inside us. It's coming. It's a little scary, but it's coming. I've seen it. I've seen a few things. Let's see. So the next piece of it is Internet of all things. So right now, IoT is kind of a buzzword, right? Buzzword means that it's a little bit cliche. But it's just like the letter E was being attached to everything 15 years ago during the dot-com days, or 16, 17 years ago now, right? IoT, internet is going to be part of everything. The chair that you're sitting on is going to have an IP address, right? Everything is going to be collecting data. Everything is going to be sensor-enabled. So there are a lot of opportunities for you to create things around that. You're going to need security for that. You're going to need faster communication path, power, all of these things, right? All these things are going to be built out. If we look at smart machines, it worked. Smart machines, so the first level of robotics is hydraulic muscles. Oh, crash. Yay, okay. So first level of robotics was hydraulic muscles. Now we're talking about hydraulic brains. So it's machines that can make decisions, all right? And if we look at the progress of artificial intelligence, so we now have software that can play games better than humans can, right? So Breakout, if you know the game Breakout, where you have a little slider at the bottom and you have a brick wall and you have a ball and you have to destroy it with. So a machine learning algorithm was given this game, and at first it couldn't play the game. After about 40 minutes, it learned how to play the game and beat it with one move, right? Better than any human can. So that's all fun, that's great, but what does that mean? Well, that means we can start applying that kind of technology now to very interesting problems. So scientists for 100 years were trying to solve the puzzle of how to model how a flatworm regenerates itself, right? So that's not showing up. So this is a flatworm, right? This is a disgusting little worm, but if you cut it in half, it'll regenerate itself, right? So scientists for 100 years could not figure out how that worked. And it took an algorithm 42 hours to figure out that problem, all right? So we already have algorithms that are smarter than a group of scientists. Last year, there was a robot called the Pepper that was introduced in Japan. They sold 1,000 units in a few minutes. And the new and interesting thing about this is that they've created this robot to sense emotions from their operator and to show emotions. And in Japan, this is a big deal because the average population, the average age is over 60 years old. So these domestic robots are going to be companions for the aging population, right? This is kind of the extreme level, right? Robots in the home, they need to show emotion and read emotion and be kind of a companion. So this is where we're headed. Now, the last and kind of arguably most interesting part is what we call 3D transformation. So if you look at pre-industrial revolution, everything was made by hand, right? The Industrial Revolution gave us blueprint design and mass manufacturing, right? And internet gave us computer-aided design and just-in-time machine production, right? So here we are today. Hey, it's working. So if we look a little bit in the future, we have 3D transformation. So it's the idea of being able to digitally design and digitally manufacture something, right? So we just introduced our printers, I'll tell you about in a second. So we have fully digital production. And where this is headed is the next industrial revolution, where we're completely democratizing design and production. This means that there will be no factories the way we know them today. There will be no logistics and delivery the way we know it today. Everything is going to be done just in place, just in time. You order something on Amazon or any other online store, and you print it out at home, right? This future is coming in about 10, 20 years. Now, we announced these 3D printers. These are, it's not showing up. So we announced our first 3D printers. These are commercial 3D printers for small batch manufacturing. We announced that in May, and they're shipping this year. It's about $150,000 entry point, but that's cheaper than a CNC machine that you would take a block of aluminum and use water jets to make a car wheel, for example, from. So that's coming, and let's see if this works. This kind of need this, guys. Let's see. There we go. Okay. So what we have is a concept of a voxel. It's a volumetric pixel, right? It's a 3D pixel, and what we can do already is be able to control the color, the transparency, soon the conductivity. So we have these transforming agents that will allow us to do different things with these voxels, right? So this is how you go voxel by voxel. You can build a product, a completely fully assembled product, right? And what that means is, in the future you'll have, just like you have electricity and water coming into your house, you'll have a pipe with magic dust that goes into something that looks like a dishwasher, and this will print out whatever you want, right? It's magic, almost magic. So let's see, the video for sure is not gonna work. Let's see. Should we try it? You guys ready for the video to maybe work? Let's see if it works. Nope, not working, kinda working. Okay, so I'll narrate. Ooh. This is, I'm the first on stage, so I get to be tested on. So you can see, this is a little bit of a ad that was put together. So I'll give you a link to the slides at the end. You can watch this, and you can enjoy it. But the idea is that you can actually print anything, and the future is just incredible. The combination of artificial intelligence and 3D printing is going to completely change the way we do everything, absolutely everything, right? So you can see this is a part that holds 5 tons, right? That was 3D printed on this printer. There's bioprinting, right? So surgeons will be able to print a body part and implant it in you and replace, it can already replace cartilage and bones with certain things. Soon you'll be able to print a lung and be able to replace a lung, all right? It's incredible things. Let's see, yeah. So I'll skip this, and I'll give you a link to the slides. You can download, you can go look at the slides and see the videos as well. So what does 3D transformation mean tomorrow, in the very near future? We're talking about completely fully assembled products. We're talking about printed electronics. We're talking about custom formulated vitamins, so bioprinting, right? You take a blood test and you have, you don't have enough vitamin D. It'll give you a pill with enough vitamin D just for you. Or printed food, things like that. All of this is coming in the very near future, well within our lifetimes. And we even have a concept of 4D printing. This means these are smart materials that will react to their environment. So you can imagine a wing of an airplane that's 3D printed that reacts to the air pressure in a different way, right? And I'll completely blow your mind with something called haptic holography. There it is, it's showing up. So this is the ability to interact and feel virtual objects, right? So first you'll see this maybe in games, entertainment. But sometime in the future, maybe in 50 years, you will be living in virtual houses, sitting on virtual furniture, right? So this is something a little mind-blowing. So speaking of US elections, so Hillary has a great quote, fail to plan, plan to fail. It's a little bit of a rework from a classic quote. But my message to you is to think about where you're going to invest your non-refundable lifetime, right? Can you beat Silicon Valley? Maybe, because the future curves of innovation are not just about software. And for the last 20 years or so, Silicon Valley has become highly specialized on software, right? So there's material science and electrical engineering and mechanical engineering, all of these things are not monopolized by Silicon Valley anymore. So the talent's all over the world. The technology can be born anywhere, right? This is why I spend so much time traveling Europe and Asia and outside of Silicon Valley, outside of the US, to look for brilliant brains working on the next greatest thing, right? So you need to think about, are you going to build the next dog walking app, or are you going to look for what's going to be big in the next 2, 5, 10 years? And that's where you're going to invest your time. That would be my recommendation. So I promised you the slides. So if you go to golomb.net/howtoweb, you can do it on your phone. You can get the slides as well as the first chapter of my book that's coming. It's going to the editor next week, right? So it's almost done, and it'll publish in January. And it's pretty much everything that I've learned in my almost 20 years in Silicon Valley in the startup world, and everything as a mentor, as an investor, that the advice that I give every day, kind of from idea to product to company. So you can get little information on that as well. So with that, thank you very much. I think maybe time for one question, if we want to do questions. Make it good. That's a good question. Does the microphone work?
While I was in the backstage, I was wondering, when will we have, virtual presentation and slides and so on, so that we won't have to face all these technical problems?
Yeah, it happens.
With the keynotes especially.
Virtual presentation. Well, first of all, we need faster internet connections and all sorts of things. All that stuff's coming.
Romania is pretty good at this, so.
Yeah, 3G.
Yeah. So, questions. My colleagues are.
It's okay. Maybe you guys need to.
I don't see. So please raise your hands if you have questions. Raise your hands, and my colleagues will bring you a mic so that you can ask Vitaly a few questions. We have one here. So could you please bring? Oh, okay. It's coming. Yay.
Thank you for the presentation. So what do you think, the question is, what do you think is going to be the first domain or vertical or industry that is going to be very strongly disrupted by AI?
Okay, so this is one of my favorite questions, one of my favorite subjects. So there are 3 million truck drivers in the US. It's the most popular profession. There are about 5 million people that support them as they drive across the country and deliver everything from the ports. In 5 years, there will be 0 million truck drivers in the United States. This will be a huge disruption to a big industry. And it could very well take out a huge portion of the population and make them irrelevant, right, as far as what they know how to do. So the first industrial revolution was, the agricultural revolution took about 250 years, right? Many generations, 10 generations across, right? The first industrial revolution took about 80 years, so about 3 generations of sons and daughters learning new things and getting a better education than their parents. This industrial revolution is going to take 10 to 20 years. It's within the course of 1 generation. And people will not have the opportunity to relearn, right, a new skill. So if somebody's been a truck driver all their life, they're not all of a sudden going to go to college and become a computer science major. It's just not going to happen. So what that means is it's a huge problem for societies, right? And US will see this first, right? This quick transition to artificial intelligence, probably within the next 4 years, within this next president's next 4 years. And if nothing is done, it's going to create a huge problem. And all of the strife that you see right now, Trump, Brexit, all the dictators that are coming to power across Europe and different countries. All of this is caused by the fact that a certain big portion of the population feels like they don't have a chance in this new economy, right? This is a big problem that needs to be solved. The answer is probably a combination of some kind of basic income that's guaranteed to everybody to be able to buy food and take care of their families, and some kind of big push into education to create kind of the average person to have a much higher education than we've had previously. So it's a little bit scary and exciting, and there's amazing opportunities in front of people that are well educated. But it is a little bit scary from kind of the macro global political economic standpoint. So, scary answer. Sorry.
Other questions? We have another one.
Hello, thank you for the presentation. I wanted to ask you two small questions. First is, can you tell us a bit more about haptic holography and how far are we into developing it? And the second one is about printing at your home. Why do we need the restriction of some magic pipe? I mean, how far are we also with the possibility to print materials from the surrounding environment, atoms, for example, without the necessity of some extra material being added from a magic pipe? So
both of these questions are Star Trek, right? Everybody knows Star Trek? So haptic holography, I don't know. I heard about MIT Media Lab. This is the MIT PhD program. There are a few folks doing research into this. And it's going to start with you putting on VR, a head-mounted display. And there are now ways for people who are working on gloves and things which will allow you to interact with virtual objects. This is kind of the start of it. How quickly we'll get to a point where we can do this on a neurological level is, your guess is as good as mine, but there's probably a lot of really good information you can look for out there. As far as 3D printing, where we are right now, we are in a place where we have on the one hand kind of what's called SLS technology. So you basically have a powder bed that goes layer by layer and it gets cured by light or by chemical agent, right? This is what HP printers are based on. And then you have something like carbon. Has anybody heard of carbon? So I recommend you look up Carbon 3D. And what they do, you've probably seen this, there's a TED Talk where they basically pull out the Eiffel Tower out of a liquid. You've probably seen this video. And it's kind of a different way of doing it, and arguably a much faster way, right? So this is all polymers, this is all plastics based. The question is where we go next from there. Next, we're looking at metals, we're looking at ceramics and different things like this, right? And it's kind of goes really deep into material science world. But some step after that will be some kind of raw material agent, which right now is this powder, that all we need to do is worry about delivering the powder. And why not put it in a pipe like we do with water or electricity, right? Deliver it wherever we need it. So that'll be the next step. If we take, oxygen or some kind of molecules and do true alchemy one day, that's probably 10, 20 years after that. So that, we're looking at the next, it's hard to predict what's gonna happen in the next 5 years. It's impossible to predict what's gonna happen 10 years or beyond. So hopefully I kind of bullshitted your answer there for you.
Vitaly Golomb, thank you very much.
Thanks.